My grandmother has led a fulfilled life. By 15, she lived through the Japanese occupation. By 40, she became a mother to 9 children. And by 60, she became a grandmother to more than 10 grandkids. But at age 85, she started to lose a part of herself, and conversely, we started to lose a part of her. She began forgetting a day of the week, cooking and housekeeping became almost impossible, and most painfully, she soon found it hard to remember us. Sadly, my grandmother's story is not uncommon. In Singapore, 1 in 10 people above 60 experiences these devastating symptoms of dementia. With an aging population, the number of patients will go to almost 100,000 cases in a few years. That's around the same number of undergraduates we have in Singapore. So far, we know that Alzheimer's disease is the main cause of dementia and it occurs by buildup of toxic molecules in the brain. These kills brain cells called neurons, which are responsible for sending signals in the brain. As a result, most of Alzheimer's research has focused mainly on neurons. Although this approach has uncovered many discoveries, we have yet to have any effective treatment. In addition, neurons only make up around 50% of the brain. I believe it's time we also turn our attention to the other 50% of the brain. These include cells like microglia, which clears toxic molecules, oligodendrocytes, which wrap around neurons allowing proper neuronal signaling, and astrocytes, which provide support for other brain cells to function properly. And this is exactly what I am trying to do with my PhD thesis, to investigate what happens to these different cell types in Alzheimer's disease. To do this, I use single-cell sequencing, which is a new technology that allows scientists to investigate diseases cell by cell. This technology works by looking at gene expression, which basically means what genes are activated and what genes are inactivated. Past technologies only enable us to look at the symphony of gene expression across all cells in the brain. In contrast, single-cell sequencing not only tells us exactly what note each cell is playing, but also whether the cell is playing the melody of health or the broken tune of disease. So, by giving us a snapshot of gene expression patterns in individual cells, single-cell sequencing can tell us what each cell is doing or not doing during disease, potentially uncovering new pathological mechanisms and, more importantly, drug targets for treating Alzheimer's. Ultimately, I hope by understanding this devastating disease one cell at a time, my research can help change the narrative of this illness from one exemplified by my grandmother's story to one of graceful, independent aging. Thank you.